We've talked about these ideas of properties of liquids and solids before, but we'll go over them again quickly. In a gas, the molecules or atoms are separated by large distances. There's lots of empty space. But in solids and liquids, the particles are touchingly close. Okay, they're very close together. They're so close that they're almost touching each other. The difference between solids and liquids, they both have molecules being close together, is the freedom of movement. In a solid, the particles are not moving relative to each other. They're just vibrating and wiggling in their position. In a liquid, they're free to move about relative to each other. So illustrations, here's the gas. There's lots of space between the particles, and they just move independently. In a liquid, these guys can move relative to each other, but they're all going to stay at the bottom of the beaker in this same volume. And in the solid, they're going to stay relative to each other in the same places. So if we identified this as molecule 1 and this as molecule 2, and we came back in an hour, molecule 1 and molecule 2 are still next to each other. Whereas in the liquid, if we had molecule 1 and molecule 2 next to each other, and we came back an hour later, they will have moved, and they might not be next to each other. In fact, they probably won't be, because they're just milling about. Okay? The difference between liquid and solid. We learned probably more than you wanted to about gases. But gases have low densities because of all the empty space. Remember, density is mass over unit of volume. So if it takes up a much larger volume, then the density is less. They have an indefinite shape. They're going to take on the shape of their container. They're going to take on the volume of their container, and you can compress them. And this is because they have very weak intermolecular forces relative to their thermal energy. Carbon dioxide is an example of a gas. Liquids have high densities relative to gases. They take on the shape of their container because the particles can move around, but their volume is fixed. You can't compress a liquid significantly because the particles are already so close together. And their intermolecular forces are moderate. So liquids are kind of between solids and gases. An example is liquid water. Solids are going to have high densities compared to gases. Their densities are going to be in the same region as liquids are. They have a definite shape. Doesn't matter what container you put them in, they're going to keep their shape. They also keep their volume. They're not easily compressed. They can be crystalline or amorphous. Crystalline, the particles are ordered like students in a classroom and everybody's sitting in rows. Amorphous might be a group of people sitting on the grass having a picnic, and they're just people randomly all over the place. Solids have strong intermolecular forces. These forces of attraction between the molecules are strong enough that they keep the molecules in position. They're moving, they're wiggling, just like you guys are breathing, but your sense of decorum and understanding of how to behave in a college classroom prevents you from getting up and running around the room. That happens in kindergarten, but not in college. An example is sugar. Sugar's a solid at room temperature. Oh, there's a lot of repetition in these slides. So the particles of a liquid, they're moving around, and so they take on the shape of the container. Here is a solid water. These are ice crystals. And the water molecules arrange themselves in a crystalline structure, and they stay relative to each other. They're not moving around anymore.